Welcome to my new series where I'm going to teach you all of AP Chemistry, and so you can get 5s on the exam. So today's first topic is moles and molar mass. So we're trying to count the uncountable. This is where chemists kind of bridge the gap between atoms or particles of something and their weight. So the mole concept. So the mole is basically an SI unit of something. An SI unit is like the commonly used unit. So like meters would be an SI unit for something. Things of that. Like it's like the common unit, and it allows us to count particles by weighing them. You know what I'm saying? So an analogy, this is probably one of the best analogies I could find is when I say I have a dozen of something. If I just say I have a dozen eggs, I have 12 eggs. I have a dozen donuts. I have 12 donuts. I have a dozen bicycles. I have 12 bicycles. If I say I have a mole of something, you know that I have this number of that thing. If I say I have a mole eggs, that's a lot of eggs. I have that many eggs right there. If I have a mole bicycles, I have that many bicycles. I have a mole of houses. That means I have that many houses. In order for me to put how big that number is in your head, because let me actually tell you what this is. This is how many particles there are in 1 mole of anything. So if I have 1 mole of carbon, there's that many particles in carbon. 1 mole of oxygen, there's that many particles in oxygen. Okay? Now, let me put how big this number is. Avogadro, by the way, Avogadro found this and stuff. Since the Big Bang, it has only been like 4.35 times 10 to the 17th seconds. It's not even been a mole seconds in our entire universe. We don't even have a mole second. Like, you understand? Like seconds, second, like that. There's not even been a mole seconds. That's how big this number is. Okay. So, we cannot count atoms because that's how many particles there are in something. You can't count atoms, but we can measure mass. So, the number underneath something on the periodic table is its molar mass. Basically, it's atomic mass unit, but it's also its molar mass unit. So, oxygen has the number 16. That means it's grams. That means its molar mass is 16. Okay. Carbon has 12.01. Its molar mass is 12.01. So we're gonna calculate molar mass, and I could show you all this, but I could also just do it. So I think I'm gonna do the do it method. I'm just gonna do it, just straight up do it. So I'm gonna figure out the molar mass of. Let's figure out the molar mass of carbon dioxide. So the molar mass of carbon dioxide would go from the mass of carbon, which was 12.01, and we have one of those because if there's nothing there, that means there's technically one. So 12.01 times 1, and then oxygen we have 16.00 times 2. This, if you do this, so I'm gonna just straight up round. So I apologize if I'm just wrong. So it'd be 12 plus 16 plus 16 is 32, right? Yeah, 32. So it's gonna be around 44 grams. It's its molar mass. Okay. Water. I'm just gonna do 2. Water. Same thing. You're gonna have 2 times the mass of hydrogen, which is 1.08, and then 1 times the mass of oxygen, which is around 16. So if you do this, it would get you I don't know, I'm just guessing, 18.02. Okay. And so that is the mass of water, mass of carbon right there. That's kind of what the slide also said. You count the number of atoms of each element. So you in CO2, there was 2 atoms of oxygen. There was 1 atom of carbon. And then you multiply the atoms by their average atomic mass. So Like you would multiply carbon by its average atomic mass. So this one right here, you would multiply by that number. And then you do the same for oxygen, like I did, and then you would add them together. So like I said, we got carbon right. It was 44.01. Water, it was 18.02. We got that right. We could have done these two, same process. You get the deal. Like sodium chloride, you just do the atomic mass unit of sodium plus atomic mass unit, or atomic mass weight of sodium plus atomic mass weight of chloride would get you that number. Okay, simple stuff. Relative weights, it's just telling you like the 1 mole of a substance varies drastically by chemical structure. So like I said, just a single hydrogen, like the hydrogen H2, it's like tiny. Water a little bit bigger, oxygen a little bit bigger, glucose a lot bigger though, because there's a lot of stuff going into glucose. Conversion highway, all roads lead to moles. All roads will lead to moles. If you're converting anything, like there's a problem that we're gonna do on the next slide. I'm gonna show you how you have to go to moles literally every single second. Every single second. No matter where you are, if you're particles and you want to go to grams, you have to go through moles first. You have to take the exit to mole. You're here, you want to go here. You're here and you want to go here. You have to go through here. Like, go through moles first. If you're converting something, you never saw the word mole, you did it wrong. Okay. So unit cancellation, I'll also show you on the next slide. But yeah. This is pretty important. If you're supposed to end up in particles of something, your number should be a positive, massive exponent. If you see negative exponent and it's particles, you did it wrong. Because think about it, there's so many particles of something. You know what I'm saying? There's so many because there should be this many like that. I mean, that's a big number. So you should not have a negative exponent when you're talking about particles. This is a question. So how many H atoms are in 10 grams of water? So we're gonna do this real quick. So we're starting with 10 grams of H2O, and we wanted to end up with H atoms. H atoms, like particles, same thing. So first thing I see is, like I said, I'm in grams. I want to go all the way out here to particles. That means I have to go through moles first. So here's the best thing I can teach you with dimensional analysis. Whatever's up here, I want to cancel grams, so I have to put grams down here. What is the first step that comes after grams? It comes moles. Because remember, it goes grams to moles to particles. Okay, and same thing. So I have to give. So how many in 1 mole of H2O? How many grams are there? And we calculated that earlier. It was just 2 times the weight of hydrogen plus 1 times the weight of oxygen. I don't know why I flipped that around. It was around 18.02 according to the slide. Now we have, let me erase this. Now I'm going to cancel out what I just did. Now we have a mole of H2O. A mole of H2O. But remember, we want H atoms. We just want hydrogen. So, in 1 H2O, this is called a mole ratio, what I'm about to do right here. A mole ratio. Pretty advanced. Like, not like crazy advanced, but mole ratio. Okay? In 1 H2O, there's 2 H atoms, right? Because H2. Okay? So in 1 H2O, there's 2 H atoms. That's what I need you to understand. So now we got the atoms conversion part done. Okay? We're not in H2O anymore. So we can cancel the H2O out. Now we're in H's. Okay? And now there's 2 H atoms. Now how many particles are there in 2 H atoms? There's 6.022. Because we're still in moles. Times 10 to the 23rd particles divided in 1 mole of anything. Okay? There you go. So we went from we went from grams of H2O all the way to particles in H atoms. So I'm just gonna multiply this on my phone, and the answer that I will get is approximately 6.684 times 10 to the 23rd. Y'all don't believe me that I did this right. We can go to Google, because I actually looked this up as well. It is right. It is right. So, like Google said, you have to first go from grams to moles. That's what it did. Then it went from moles of H atoms. It went from moles of it did the molar ratio. Basically, it's what it did. Like I did the molar ratio. um and then it got this number. So, good luck, guys, and stay tuned for part 2.